Hello and welcome to CTEC's EnterVol training videos. In this video we're going to build a model using EnterVol's Geostat from some total hydrocarbon data. So we'll begin, we'll bring in an Excel spreadsheet in a folder that I've already added. We have both horizon and boring data as well as total hydrocarbon data for this particular site, which is called the painting facility. So our first step is to create a new EnterVol project. So we'll call it painting facility. And this particular site, the data is all in a local coordinate system in feet. So again, we'll just give it a quick name. At this point, we can import our data. So we'll start off by importing the borings that were defined here. And these are defined in this horizons sheet as simple vertical borings. And our ground surface is given as well as the bottom of the borings. So we can accept all the defaults. And when this is finished, we can add them to the map. They're added to our table of contents. So there's our borings. And we're going to add some analytical data now. Again, we're going to import from the total hydrocarbon spreadsheet. And this is analytical scattered point data. So we have X, Y, and Z coordinates. We could actually use depth also, but since they're both relevant here. Our analyte is total hydrocarbons. We don't have a column specifying detection limits. So in this case, we're going to tell all the defaults here and that we're working with total hydrocarbons. We can finish. And once this is finished, we can add that analytical data to the map. And so we have data that ranges from 10 to the minus third to 81,000. The 10 to the minus third, because the data is log processed, so our zeros become 10 to the minus third, and that's a value that's set in our project settings that we can change if we wanted to. So here's our data. We can increase the vertical scale to look at it a little bit nicer. And so we're going to build a model using this data. So we go back to the modeling window and down to models. And the first step is always to build a 2D grid. So now there's no other options but to build the grid in the XY plane. So I'll just give this a quick name. And there are several options by which we can build the grid. And we're going to choose the default, which allows us to build a grid based on the convex hull, which is the spatial extent of the data. We're going to reduce the offset from the default, change it to be 5%, and we can do a quick preview of what this looks like. So if we go to a top view, we can see that the grid is built around our data, not just our boring here. The grid is adapted, it is modified so that we'll have nodes landing precisely on our borings. And it matches the extent of our data. We have rectilinear grids and even a concave hull, which we could get it to kind of swoop in and cut out this region if we wanted to. But I think this grid's going to work fine for us. Now the only thing about it that I might change is that notice that the triangle cells, quads formed by two triangles, are slightly rectangular. So if we want to make those more ideal squarish cells, we could go back to the modeling window in our XY grid here and just increase the X resolution. Let's just try 70 and see what that looks like. We'll update the preview. And that looks better. So we're going to go with that. All right, at this point we can build a 3D grid. And it's going to be defined by the tops and bottoms of our data points or our borings. So we can see how we like these defaults that it picks for us from the data. And if at any point we don't like it, we'll just go back and build that grid again and update it. So we can display this 3D grid colored by elevation. Let's close and look at this. So all of our borings and samples are in there. Let's take this and make it transparent so that we can see inside of it and see how the data fits in it. Now notice that there's really no borings as tall as no samples as tall as the highest boring. So if we wanted to, we could change, and if we had a ground surface in here as a horizon, we could build a grid based on that. But that's getting into some features that are in interval geology. So we'll just stick with this grid. We don't really need to see this 3D model anymore. I'm just going to turn it off and go back to the modeling window. And now that we have a grid, we can add analytical estimates to it. So it populates our kriging with some defaults. It'll build a variogram for us. There's a horizontal, vertical, and isotropy, which accounts for the differences in conductivity in the soil between the horizontal and vertical directions. We can change these and see how it affects the plume, but we're going to accept these defaults and build a model. So now it's updating for us. It's telling us what it's doing. Right now it's going through the process of building the variogram, fitting the variogram model, and at this point it's doing the interpolation. That's done. We've handed the model off to ArcGIS to render, and now it's giving us the options here for the data. Now the gridding doesn't give us a value that's exactly what our maximum, but I noticed our maximum value was 81,000, so if I choose that same max, then the symbology for the concentration data that in our 3D model will match our point data precisely. And here's our model. Now, this is the model, the outside surfaces of it. And so if we want to see what the plume looks inside of it, we select the total hydrocarbon model and use the plume tool. Now let's do a plume at 1 part per million. It's going to copy the symbology and hide this model so that we can see the plume. Otherwise it would be inside. And there we are. And we can also slice. We still have the total hydrocarbon model here. We can do some slices. And we can orient those slices arbitrarily. Now right now the slices is oriented perpendicular to south, so we can grab and rotate it and put it anywhere we like, move it around with the X and Y sliders. So let's put it through the middle of the model there and tell it to go. So if we turn off our plume, we can see our slice better. You know what would look nice here would be some edges on this model so we can kind of see the extent of our grid. So we do that right here with the edge tool. And now let's do a cut. Now a cut is different from a slice in that a cut is leaving a solid portion of the model. So I'm going to orient the cut to go right through the hot spot there. And so we'll be getting this half. We could reverse the cut and get the other half. Let's just stick with this half. And again, we can turn our plume back on. You know, and actually I'm thinking I'd like a new plume at a much higher level. So let's set the plume to be up at about 1,000. So let's do a plume at 1,000. That looks good. So there you have it. A quick example of building an analytical estimate model using nothing but a single spreadsheet with some XYZ scattered data, all done with EnterVol Geostats and the EnterVol core component, EnterVol for ArcGIS. Thank you for taking the time to watch this video. Stay tuned for more episodes.